All right. Hope you had fun with that. If anyone was watching, just thought I would show these old trailers that we put together. Anyway, just to kill time, it's about to be 9:15 here. I think 7:15 over there on the East Coast. Yeah, I think today I want to cover the initial steps we are going to implement for rollbacks. Uh, I'll give people a few minutes here to file in, as you will. Uh, how's everyone doing this morning? Well, this evening, I guess, out there. Make sure everything is running okay here. It looks okay. Cool. Alrighty. Again, I'll just give a minute or two for people to come in. But yeah, if you're here last time, I think we covered debugging desyncs, which is basically involved just logging. Yeah, we would show these logs, or just compare logs basically from network traffic. Anyway, let's see. Let me pull up some stuff here. Make sure everything's just running. Everything should be okay. Yeah, there we go. Okay. Alrighty. One more minute here and then we'll get going. I was feeling a little more motivated this morning, so I decided to go ahead and start the stream. I didn't know if I was going to do another one this week, but might as well, I thought so. Okay. It's like about 9:15 here. That's when I said I would get started. I'm planning to do about an hour. We'll see how far we get. Okay, just before we go, I just want to cover our agenda here. The first thing we're going to have to do when implementing rollbacks, we need to make sure we can let the game forward simulate without waiting on the opponent's input. As you know, with our initial delay-based implementation, so-called deterministic lockstep, if we don't have the input for the other player that we've received over the network, we can't forward simulate. If we do, we'll become desynchronized. But actually now, for rollbacks, we're going to allow the game to desynchronize just for a little bit, and then we're going to fix it later. So yeah, the first thing we need to do is actually unlock that simulation. And in order to fix the desynchronization, we need to restore back to the last known synchronized frame, synchronized game state, then rerun the simulation up until the current frame using all possible inputs that we've received from the opponent already on the appropriate frame. That way we'll be more synchronized than we were before the rollback. And we'll repeat that process over and over again. One of the things we're going to have to do is we're going to have to store the predicted inputs. Now, the predicted inputs are just inputs we're going to use from the for the opponent, for the other player, when we don't know what the inputs are yet. And in this case, for fighting games in general, we're just going to repeat the last known input. That's a really likely case, as players can't really hold and release buttons very quickly. So usually when you hold a button, it's going to be for several frames, and when you release it, it's going to be for a good number of frames. It's not going to be like on, off, on, off, on, off from frame to frame. And then we're going to limit the number of simulated frames. So we only can store so many inputs from that we're predicting, right? And also we don't want to get so far out of sync with the player that we're going to have these giant rollbacks. So we're actually going to limit the number of forward simulated frames until we pause, like we would do on delay-based netcode, to wait for the opponent. Unfortunately, if the game becomes so, we're gonna make this limit pretty high, maybe 10 frames or so. If you're that far out of synchronization with your opponent, you might as well not be really playing a match at that point. Yeah. So, and then we're going to compare our predicted inputs with the actual inputs. For any frame where we predicted correctly, we don't need to resimulate that frame. We can jump to a frame after that frame because we know it's synchronized. So we don't have to simulate as many frames, and thus it's not going to really matter here. But in rollback implementations, there's a cost to actually resimulating a lot of these frames. So yeah, and we have some code that determines whether or not there's a mismatch in the inputs, and we'll resimulate or restore the frame. Sorry. Yeah, we'll store the game state, then resimulate up to the current frame. Restore the last known synchronized game state, then resimulate the current frame. And we're gonna deal with clock synchronization here. I'm not gonna get to that today. I don't know if we're gonna get to this part today either, but we'll try to do at least this. Okay. These are just my estimated times, how much this can take. It could take more or less, I don't know. Yeah, so with that, let's get started with coding. Okay, so the first thing I'm going to do is unlock the game sim. Right now, actually, when we run the game without the network mode, we can't update, and I want to test our ability to just simulate the game state up until our frame limit for rollbacks. Right now I can't update, so what I'm going to do for testing purposes is when we're not online, like when this network mode is no connection, I'm just going to let the game forward run just for testing purposes. So here, so down here, update next frame, I'm just going to put here to override everything. Sorry. I'm going to put a check here. So this seems to be true. So oops. It's not going to give me prediction here. Okay, that's fine. Okay, this is going to allow us to basically run the game when we're not connected. Okay, so if I run the game sim or run the game here, I should be able to update. So you can see the game frame count's moving, so I can move my player around. Okay, cool. So it looks like for offline we have this. I put unlock game simulation for network sync here. I'm actually going to move that to after this because I want to test state saving. It's not going to be that difficult. I just want to test that offline first. So did I put any keyboard inputs in here? Is keyboard. Here we go. Great. I don't want this code anymore. I might not use it. Yeah. I don't like to. So what I'm gonna do, yeah, I'm not just gonna use this at all. That was just for debugging network play. So I'm gonna do save state here, and we're gonna restore state here. Oops. And we're only going to do this on offline mode. So, sorry. Where's that code? Yeah. So we're only going to allow this when there's no connection. Oops. Okay, else. Sorry. Okay. And we're going to have to store our game state somewhere. For now, we're going to store one game state. I'm going to get to storing multiple game states later, and I'll explain why we need to do that. Okay. Write it. So I was going to say saved. Okay. Okay. And of course, before we start the game, we need to make sure the game states match. So this is just a plain data structure, so I should be able to just copy paste. So copy paste mem copy. Yeah. So before we start the game, store the initial game state. Okay. So we should have be able to mem copy. Sorry. Oops. What is it? I think it's destination source size, but I just want to make sure. Oops. I'm going to open up my stream setup browser. Okay. Let's see. Just in case. I usually have like Visual Assist X or something to show me. Really? It's giving me Japanese, of course. Okay. Yeah. Destination source count. Okay. Anyway, let me double check. This should be, yeah, it's giving me my browser lately has been giving me a lot of Japanese results because I live here in Japan. So unfortunately, that's really annoying. What is it picking up there? Oh. The camera's picking up something. Oh. Still? Okay. Okay, we should be good. Hopefully it will stop doing that. I don't know why it's picking up a background now. Anyway. Okay. Okay. Yeah. That was my controller. One thing I hate about game development is these damn control. I don't have one of those giant mouse pads, so they just freaking slide off your desk constantly. Okay. Anyway, yeah. So we should be able to do this game state. Is it game state? Size of do this. That should work, right? Okay, and then we should be able to, I'm just copying, basically what I'm doing here is just copying the structure that stores our entire game state. This should entirely determine what our the results of the next frame will be. So, okay, let's see. So when we press F1, store game state, and when we press, what is this to say, save game state, and restore game state, and we're gonna do the opposite of here. We should be able just to do right. I'm just gonna do this just for posterity's sake. It doesn't really matter because they're both the same size, and that should work. So we should have store and restore working now. Let's give it a shot. Okay, I'll move things around. F3 should restore. I'm pressing F3. Now if I want to store a game in a certain state, I press F1. I want to move things around. It goes back to there every time. Okay, there's a rollback. We're done, right? No, not really. Okay. We got it testing. We're going to assume it's going to work as we expect for now. Now, what we need to do is actually let the network simulate the game forward without locking because of lack of input. So before we get entirely to there, I want to add a flag that controls whether or not we're using rollback mode or input delay mode, so that we can jump back and make sure everything's working as we expect. So I have arguments here for da-da-da-da. Let's see. I'm going to add just another case here. This is not the best way to do command line arguments, but this is for testing purposes. I'll fix this all up later if I submit this to GitHub. Okay. So what does that have? What do I want to do? Let's do this. Okay. So let's do D for delay based. And then I'm just going to add another enum up here. Okay, let's just say lockstep and resim. Well, let's just do rollback for now. Okay. And then we're going to have a new variable that controls which mode our game is in. Okay. By default, I'm just going to set it to rollback. And if we want to go back, I'll change it. Let's do rollback. And if it's D, I'll just set it to lockstep. Okay. Okay. So we have that set up. This is the first argument, second argument. Okay. Let's see. I could test that, but we'll test it here in a second. Now I have to check this variable in various places. So it's called net sync type. I'm just going to note that. Okay. And then when the check we do to make sure that we don't simulate forward, which is update next frame here. Right now, if the latest network frame is greater than the frame count, then we simulate, right? That is the lockstep mode. So we're just going to set that up for, sorry, I have to, yeah. So we're going to do this, else if, hold on, lockstep. What did I do? What did I do wrong? Oh, fix it. Okay, netsync type unless it's lockstep. And then in rollback mode, we're going to do something differently. But in lockstep mode, we're going to limit the frame by this. So right now, we're just going to let you simulate forward all the time. So okay. What did this do here? Okay. So right now, we're just going to allow force him. It should just work. Let's build and see what happens. Okay, and let's run the game. Okay, we're force simming. Cool. Well, here's the we don't really know what's going on here. So let's add some input, the network latency, things like that, to test the effects of this. Okay. So I'm just going to add, yeah, okay. Let's add UDP. Let's add some lag. 200. So it doesn't seem to affect it at all, as you can see here. Okay. Let's try that one more time. So since we're allowing forward sim, give me a second here. No, I'll get rid of that. Sorry. Go back to my projects folder real quick. Projects. What's the wrong one? Okay, here we go. Okay. So we have this lag added. What if we add some frame drops? Okay. We're running, right? But you can see now we're out of sync, right? Like, we're absolutely out of sync. And it's because we're forward simulating without checking whether or not we have the inputs for that frame. And actually, if we do a comparison here between the sync logs and we should see the desynchronization in the input itself, right? So the inputs were different on both sides for each particular frame. So it's out of sync. So looks like we've saved restore frame supported, unlock simulation, and now what we need to do, I'm going through this pretty fast. It's only been 15 minutes. Well, okay. We need to store the predicted inputs because if we don't, well, let's see how we're gonna do this. Yeah. So, because all these steps kind of need to go together for us to actually properly roll back and do things. So we need to store predicted inputs. Do we need to store predicted inputs first? That's what I'm thinking. You know what? Let's change that. What we're going to do for now is just roll back whenever we get input. Instead of checking anything, we're just going to roll back when we get input from the other player. So roll back. So we actually need to run we need to store resimulating when we roll back. Okay. We already have the input buffer, so we don't need to actually do anything special about storing up our local inputs, but we can just reuse that. Okay, so what we need to do is we need to add a loop to our simulation here. So firstly, let's just start num of resim frames 0. Okay. We need to okay. Okay. We'll start with this 1 for now. And what's next steps here? Well, we need to calculate how many times we need to resim. Resimulation is going to be based on how many frames we run forward without input, right? So we need to record how many frames we are ahead of the opponent without receiving input from them, okay? So what plan here is to check to see whether or not we would normally be able to update forward like in lockstep mode. If we can't, then start counting. So we previously added this code here for checking to see if latest network frame is greater than frame count. If this is not true, okay, if this is not true, which means basically this is a head of, so basically for a head, so then we're gonna be in counting mode, right? So I'm gonna add a new variable here at the top. We can move this later. I'm just gonna say out of sync frames. Set that to 0. Come back down here. Where were we? So if we're in rollbacks and out of sync frames, we're gonna increment this, right? Otherwise, we're gonna set this to 0. That should work. Unless I'm oversetting something. Okay. So we're gonna count how many out of sync frames we are here. Now, we might have to change how this works when we limit the number of frames we simulate forward, but for now, we're just going to do this. Okay, and once we eventually decide to roll back, we need to take that variable and decide how many frames forward we're going to simulate. So I'm going to put this up here. Okay. We're probably not going to have the number of frames up to the current point here. So what we're going to have to do is once we you know what? I'm gonna record off the first frame, the last frame we were synced, okay? Or the first frame we're out of sync. Give me a second here to contemplate this. Okay, we might be having off by 1 error, but we'll try. So let's see, if out of sync frames 0. This is when we haven't got out of sync yet. This is what I want to do. Let's step through this real quick from going back to the beginning. Let's check. Okay, so let's go through our logic again. So what we're going to do is when our frame count is above, which basically this frame count at this point is going to be the frame we're about to update now, right? Because at the end of the game simulation we update the frame count. So before we update, say, frame 0, the first frame of the game is going to be 0. Okay. Assume we're on like frame 1 and the last network frame was 0, we're ahead. So we need to update the out of sync frame. So because we're about to simulate one additional frame past, you know, the frame we had input on. So they'll be out of sync frames by 1. That makes sense. But you know what? What I want to do is not record this here. Actually, I want to record that here. Not here. So for each simulation frame, I want to record it. So So every time we simulate, I'm actually going to record how many frames we've been out of sync. I'm not going to set this back to 0 here. I'll explain why in a second. We'll handle that in rollbacks. So this is going to let us know how many frames we need to roll back. Okay. And when we decide to roll back, how do we decide to roll back now? We decide to roll back when we have frames that we didn't, input for frames we didn't have previously, right? So we need to record off when was the last time we had input, right? Okay. So I'm going to jump back here on this code, this network part of the code we had here. Do the same kind of thing. Just here. I might change this a bit. But so when we're ahead, when we decide that we're ahead, we need to record, for now let's say let's record the last frame we had input. So, well, not the last frame we had input for, but the last frame we actually used input on before we got out of sync. That's the idea. Because once we're out of sync, it doesn't really matter. We only care about the last frame we actually had input on. So, what's the best way to do this? Because the truth is we're going to probably be out of sync most of the time just by a little bit in rollbacks. So which means we're not going to have a latest network frame that's higher or equal to ours. So we need to, the way I structure this code, which is what's the best way to do this? Hey, what's up, Creed? Just doing some rollback stuff here. Okay, let's think of this from the beginning. Okay. Let's run a scenario in our head. So we're running the game, frame 0, fine. We update the game, frame 1, frame 2. Let's assume we're kind of a little bit out of sync in the first place. So at frame 0, we're fine. Frame 1, we're ahead by 1 frame, right? We haven't received input for frame 1. We got it from frame 0. We go into frame 2. We go into frame 3. Let's break that down. So we got 1, 1, 2, 3. So this is our first update cycle here. Once we get to frame 4, let's assume we've gotten input for these frames and no input for these frames. Okay. So what we want to do is we want to resimulate, go back to frame 0. Let's just say we had it here already. And, oops. We want to go back to frame 0, restore where the game was at frame 0, or after we simulated the game, the 0 frame, not before. And then we need to rerun 1, 2, 3, and 4, which makes sense. So how do we determine that? Well, let's start at the initial state. The initial state, we know already. So the initial state of the game is we run frame 0. We know that the pre-frame before frame 0, the initial state, is synchronized. Okay. So we can always, the base case is we can always restore to the initial state of the game, right? So let's think of a little simpler scenario. We start at frame 0, we run it. Let's see, it's out of sync. Okay. We get to frame 1, then we have input for frame 0. We need a rerun. So what do? So in this case, we restore initial state. Well, so we restore the initial state, restore of the game, and then we rerun the game simulation too. Rerun game simulation. So in the base case, we know it's initial state because we haven't done anything yet, right? And then what do we need to do? Well, it's during this store the frames which we have input for. So we're going to go off and store each frame as we're simulating so that we can restore back to that frame if we need it. This is just a simplification. We'll optimize this later. So we need to store off that frame and which frame it was. So during simulation, store the frame which and the frame number. Okay. Let's just say frame count. Okay. So for now, let's say bool is resimulating. It's false. We might change this to true. Okay. And then after we've done the full simulation, then we're going to store off the game. If we have the input, right? If we have the input. And how do we know if we have the input? We know we have the input if this is true. Latest network frame is greater or equal to the current frame count, right? Well, we need to know if we had input for this frame. So it's actually not going to be here. You know what? I'm just going to put this in because it's going to be easier that way. So go back to this mem copy thing. So first of all, we're just going to say we're restoring this, and if latest network frame is greater than frame count. Because this frame count here indicates for the next frame actually. To get the frame index, we have to subtract 1, basically. So say like if we have input for frame 0, this latest network frame value is going to be 0. And if we just simulated the first frame of the game at index 0, it's going to increment the frame count to this. You have to subtract 1 to get 0. I think that makes sense. So it'd be 0 is greater or equal to 0 is true. Then we know we're synchronized and we can store it off. I think that's right. Okay. Oops. What was that in the agenda? Decide to roll back when mismatched inputs. Said roll back when we get input from another player and resimulate. So also we had to do this too. We had to store off game state during resimulation when we have input for each particular frame. We had to do that. Store off, okay. I was going to say we also need to record which frame this was, right? Okay. So we need another variable, last stored game state frame, something like that, before the while loop. Okay. Last stored game state frame, something like that. Okay. Yeah. And last stored game state frame. And actually, this is not going to be 0 initially because we don't have 0 is actually the first game. It's the index for the first frame we've simulated. So I'm going to get to how this becomes useful later, but yeah. We could do it 0 and just do some math later. I might change it, but we'll see. Record the frame of the last game state frame that was stored, or that we saved. Okay. Anyway, so we got that, and then we need to do this at the bottom. We need to store off this one. We might change how this works. Okay. So we're storing off the frames now. That's great. So we know which frame we need to restore back to. We need to decide when to roll back though. So we need to look at this last stored game state frame and make a decision. Okay, where are we going to make the decision at? Let's just start here. So let's say if last stored game frame state is greater or it's less than our latest network frame. Okay. Less than the latest network frame. Or, put it this way. Basically, if we have newer inputs than last time. So if we got frame 0's input, we can do this, right? Because latest stored game state frame, yeah, latest stored game, I'm going to rename, latest saved, saying stored is kind of difficult, so latest saved game state frame, then we can actually resimulate, right? So we're going to say resimulating equals true. Okay. So we can indicate that we're resimulating. We're going to set this to true as well. We need to decide how many frames we need to roll back to, right? Well, first of all, let's just, where's that code for restoring here? Yeah. Okay, so okay. So we're going to restore this. And we need to determine how many frames we need to simulate to. Okay. So it's basically, let's say we're at frame 2 now. We got input for frame 0. We'd restore back to frame 0, right? How many times do we need for to simulate? So frame 0 is 1, frame 1 is 2, so 2, right? And then 3 for the current frame, if you want to do it that way. So this is -1, for example, right? So we need to take the latest game frame count minus, this is just the brainstorming here. Before we update the game for 0, 1 for the third time, it's going to be 0. It starts at 0, becomes 1 and 2. Let me, yeah, it starts at 0, I think it starts at 0, right? This is one of those things that get difficult. Yeah, it starts at 0. It starts at 0. Goes to 1. And it goes to 2. Then 2 so 2 minus -1 is going to be 3, right? I think this. So that's going to be what we want, I think. So we don't want an if here, not an if. We want resimulation count. Where's that? Did I make a variable? I thought I made a variable there. Okay. Anyway. Wait. I thought I made a variable. Did I lose track of it? Okay. Anyway. 1. I thought I had a variable. I don't know. It's probably somewhere. So we're going to have to record how many times we update the game simulation. Normally it's 1, but during rollbacks we need to do more. And then this is going to be equal to this. Let's do just another sanity check. Say we're at frame 5, and the last time we recorded input was frame 2. 5 minus 2 will give us 3. So we rerun number 3, 4, and then 5. Okay, makes sense. Great. Okay. So right now we have an if loop, if update next frame. It's going to be a while loop, well, for loop actually. Let's see. It's not really a count. Okay. Anyway, I don't know if we're going to use this or not. We actually might use it for something. And actually, we have some rendering stuff we do. I'm not going to worry too much about that. I think this is how I want it. Yeah, all this rendering stuff I'm going to move. Not that stuff. This logging stuff. Oh yeah, we want to keep the log here actually. Okay. The logging is going to be tricky because we don't want to log. I'm going to get back to this actually. We're only going to need to want to log the last synchronized frame. So I'm not going to deal with it right this second, but we'll get to it later. Okay. Gotcha. This out of sync frames thing, I'm gonna need to move this. If resimulating, hold on, move this to here. Oops. It's not just here actually. Are we using this actually? We might actually use that variable anymore. We'll get back to it. Yeah, we're not using it right now, so I'm just going to comment out. Hold on. Okay, so double check. It's a lot of stuff, I know. Getting close to the hour mark too. So I just want to get to the part where we're like actually rolling back and doing that work while playing online and seeing how close our game stays synchronized. So let's step through this. So hold on. I'm just gonna put some brackets around here. Okay. Okay. So we run it for a number of frames. Each frame, if we're in a resimulation mode, if the latest network frame is greater than frame count minus 1, we're going to store off this frame count. Is this correct? I think this is correct. We can safely say during a resimulation, if our latest network frame is greater than equal to the current frame count minus 1, we can store that off in the last state frame. Okay, so this is our synchronization mechanism kind of thing here. This is actually what keeps track of the synchronization frame and the state. And then we had some stuff up here. So the latest network frame is greater than the last. So this is when we know we have input. So say we stored frame 0. We have input for frame 1. Then we can do this. So is resimulating updating frame is true. We calculate that and then copy over the last game state, and then we do everything. Okay. Here goes nothing. We can see what happens. I don't expect this to work on the first time, but we'll see. Okay. Okay, we are forward simulating, and we're getting nothing. Why are we getting nothing? Okay, so opponent's inputs come from input history, opponent side, and game state frame count. Okay. What do we miss? Oh. Get rid of this real quick. This should indicate whether or not we got inputs, right? I think so. We're updating input history no matter what. Huh. What did I miss? Well, for now, let's see. Let's disable. Let's disable this for now. See what happens. So the simulating part is not the issue. Okay, that's good. So what is the issue? What did I change that broke this? Well, let's update this real quick. I was gonna say, what was it, D and D? Okay, let's see. So it should be in lockstep mode now. So lockstep mode works. Yeah, with the delay. Oh, I just realized we're still running this, right? Hold on. Okay. So lockstep mode works still a bit with the delay. That's okay. So it was something to do with the network latency that was causing issues. That's what it was. Okay. Let's turn down the lag and turn off frame dropping for now and see what happens. Okay, it seems to work. Let's see. Where does it break? Let's see. Let's add more lag. If we do 200 milliseconds, does it all just break? Doesn't break, but it's choppy, you can see. You can kind of get the effects of rollbacks. Or are we getting effects of rollbacks, huh? Interesting. We should be in rollback mode, right? Give me a second here. Let me double check that. All right, we should be in rollback mode. Okay. Okay, we're running smoothly. Let's add latency. I think it might be hard to tell if we're rolling back or not. It does look like it's delayed, right? Let's change the speed of these characters. Move speed. Let's just make it really high. That should make it really more obvious. Oh, we're still running. Okay. Okay, moving really fast, right? Let's turn on latency. So we're seeing it come out with a delay. Doesn't look like it's rolling back, is it? It just looks like it's delayed, which is not right. Okay, hold on real quick. Let's attach the process. Let's see. Let's go to host. Okay, and okay, we are doing that. Let's see if we're doing resimulation. Looks like we're never resimulating, despite the fact that we have a lot of input delay, a lot of delay. We're never resimulating. Yeah, look, it's just a huge amount of delay that comes out here. So, yeah. We have not one side of rollbacks, but one side delay. So, yo, what's up, Tony? How you doing out there? Okay. So we messed up something. It's not resimulating. Why? Okay, let's check back here again. The latest network frame is greater than the last saved frame. Then we're gonna take the difference of the current frame, last saved game frame, set up the simulated frames, restore the game state from the saved game state, go from sim frames to the current sim frame to simulation frames, yada yada yada. Run through this. If we're resimulating, we store it in the latest network frame is greater than the frame count, then we store off that. If not, no. And we save the game state. So what's the issue here? What's happening? What's broken? Well, I'm going to disable some of this logging for now because it's going to be very verbose. So, but I'm going to dump this. So, rolling back. So we're going to roll back. How are we going to determine this? Back. We want the latest network frame here. We want the last save game here. And then we want, what else do we want? We want the game state frame count. Okay. 2. Just need this. Need this. We should be good here. Oops. Did I kind of close everything? Okay. Okay, let's rerun the game. Okay, we should be able to see the log here. Let's turn on the lag. Start the lag machine, the lag switch. Kind of looks like rollbacks actually. Let's turn up higher. Super high. Oh, I'm an idiot actually. Oh, we're getting nothing at this point. We're so out of sync. Okay. So 300 is no good apparently. But I just realized something. I know why we're not seeing a lot of rollbacks. My input delay is really high. Let's just set that to 1. That's probably the whole issue. It's probably working actually. Let's do it again. Okay, and let's turn on the lag. No, it still looks like it's just delayed, right? Doesn't look like it's rolling back. Okay. Let's go back here and look at our log. This today, right? Yeah. What are we recording? Oh yeah, we still have the network latency. Okay. So we are deciding to roll back. What's going on here? So latest network frame is 235. So this is 1 frame ago. We should be getting, these values should be way different. Let's go to the top. Oops. Oops. Let's go all the way to the beginning. So 1 frame sounds about right if we're not having any lag. But when we have lag, rolling back latest network frame is 111T. Last game is 2 frames. Okay. So it looks like it's still taking about 2 frames for... Huh. So this is when we stored off the last game state, and this is the frame we got input for. Why is it only 2 frames different? It should be much higher. 200 milliseconds divided by 2, 100 divided by 16.66 milliseconds. That's what? Around 8 frames lag? Or, hold on, I'm just gonna calculate real quick. That's 6 frames of lag. Okay, so it should be much higher. Well, obviously, the time between doing this is pretty high. We have about 9 frames of rollback here. We're running up against our limit on how many frames we store off from the network, or send over the network. So we could get complete desynchronization because of frame drops, but what's going on here? What is the issue? Let's disable some of that network logging. It makes it a little difficult to read. I need a program that lets me filter out that stuff more easily, but comment this out. And let me open up a terminal here. Okay, and let's tell F. Oh yeah, I don't. Okay. Stop this real quick. Do we have lags? Okay. Let's start the game again. Let's build. And then run. Not here, but here. Okay. Well, then we should have. Oops. To be able to do this here. Looks like. What is this input? Oh, we're still logging the input stuff? Hold on. I don't want to do that. I want to disable that too. Thought I just. Okay. What was that? Okay. Yeah. Okay. Let me rebuild this. Rerun it. And we should get some login. Okay, so we should be able to see the rolling back here. So it's not that far off, as you can see, like 745, 744. Though the frame count is pretty far ahead. We add some latency. So what we should be seeing is not, instead of there being delay, we should be seeing like a jump as it's resimulating the game. Okay, let's close this. So we're seeing rolling back. So let me double check this real quick. It's pretty far ahead. Our game simulation is pretty far ahead of latest network frame. That's a lot. That's like it's 11 frames there between here and here. That means it's taking 11 frames for input to arrive, which doesn't sound right. Or we might be just that far out of sync. Open up another terminal here. Hold on. So, yeah, we might be out of sync though. Well, both game state frame counts seem to be pretty close on the client and the host. There's only one off. It's interesting. But still pretty far. It's like 10 frames from the latest network frame and the frame count. So that means we're only rolling back 2 frames, which are... Something's not right there. Why is our latest network frame so far behind? We should be rolling back from here to here, so that's a good number of rollback frames. Something's not right. This is when I make estimates for how long this stuff's going to take. You run into these bugs like this, and you have to go, okay, this is actually going to take longer than I thought, because things don't work, almost never work as you expect it initially. So, yeah. Why would it seem that our network frame is off or so far off? Okay, let's rerun the game without lag and see what happens. I would only expect the network frame to be basically 1 frame at most off. So let's look at this again. What are we seeing? We're seeing on both sides, we're same frame count, which we kind of expect. The latest network frame is just ahead and just on the same frame here. So that's kind of what we would expect, right? Okay. Let's add some lag. Let's say 100. Oh, it's 200. I'm an idiot. I thought this was round trip time. It's not going to be 6 frames. It's going to be 12 frames. It's exactly kind of what we're seeing is 12 frames. Oh, so because this is inbound and outbound. This is not round trip. I was dividing by 2 by habit. Yeah, so I would expect I get about 6 frames of difference here if I start this. Okay. Do we see 6 frame difference here? Frame 244, 29. That's about, yeah, that's about 6 frames on that side, and 236 frames on that side. So that's working correctly. You need to check your assumptions all the time, because often there isn't an issue where you think it is. It's just your assumptions that lead to false conclusions that are tripping you up. But still, why does it look like it's delayed instead of like an actual big rollback? That's a good question. I'm going to get crazy here. No, crazy in relative terms, and increase the move speed of these guys and see what we see. See how things are turning out. Okay. Stop this and then run the game. Okay, everything looks fine for now. It's really fast. We really should be seeing rollbacks if I'm doing this right. Does it look like rollbacks? Honestly, I can't tell. It's not running smoothly, that's for sure. Smooth over here, choppy over here. If I increase it, let's see how far I can go. Nah, it's too far. We're out of sync now. Yeah, permanently out of sync. Yeah. Well, 1 is ahead, 1 is behind, so maybe it's working. It just doesn't look like rollbacks. I would expect more big teleports. How do I put this? How can I make it more obvious? Well, for now, let's go in here, and I actually want to print out the number of frames we're going to resimulate. So, where are we doing this at? Let's just say roll. Add one more variable here. I'm going to write this off to see how many frames we're resimulating. Just to check. We could do the math in our head, but why do something in your head when you can get the computer to do it for you? I'm going to close all this, rebuild here, and run. Do we have lag on? No, we don't have it on yet. Great. Turn on the lag. Okay, here we go. Woo! Okay, let me close this and check the game. Simulation frames 13. I don't know if it's because of the game so simple that it's hard to see the rollbacks, but we definitely are resimulating this number of frames. Okay. Let's double check this. So we are getting pretty much what we expect. 12 plus 1 frame of rollbacks, resimulation. Setting that to 0, running this number of times. Yeah, yeah, it's kind of appears, but it's not as broken as I expect it to look. That's the issue. Okay, how much time we're running up on here? Oh, an hour and 20 minutes already. Wow. Okay. So, yeah. This is a pretty high number of rollbacks, actually. Yeah, it's weird. It's really weird. I don't get it. Maybe because the game is so simple that so what are you seeing here? It looks like a delay. It doesn't look like I'm moving player on the left side. This looks like a delay. It doesn't look like a rollback, but again, it might just because the game is so. It definitely is moving in large steps, but also looks delayed, which I don't expect it to be delayed like that, but maybe my intuition's wrong. Maybe that's the correct behavior we should see. Well, anyway, for now, it looks like it stays in sync. We have no issue here. The rollbacks seem to work. The only problem is we can get one side of rollback. And maybe I can demonstrate that here. Where one side is smooth and one side isn't smooth. So how can I do that easily? Maybe it's one of the easiest ways to do it is like to grab the frame. But unfortunately, how do I do that? I forgot how to grab a frame in Windows. Can I? Well, unfortunately right now, I don't have a way to demonstrate the one-sided rollbacks that could happen. But next time, I guess I'll get to doing that. I'll put that in the agenda here. Okay. Okay. Let's just say next time. Okay. Alrighty. Cool. Looks like we got through a lot. Yeah. But we got rollbacks working to a certain degree. I'm not entirely confident. Oh, because it looks like it's working way too well. Yeah, we just desynced. But yeah. Next time we'll get to these other things that I'm listing here. If there's any questions before I cut off here, just let me know. Otherwise, I'm going to end it here. I need to go find my phone. Oh, there we go. Pop my sternum. Yeah, our good little stream made quite a bit of progress. I know a lot of stuff got covered really fast. And I apologize if I kind of like went over something a little too quickly. But when we finish all this, I'm gonna let you guys have a long question and answers session if you want. Yeah, cool. Well, yeah. With that, if there's no questions, maybe I'll give you a second here to ask if you have anything. I will cut the stream off for today and get back to it next week. Let's say give it a good minute or two here. Oh, one way that we can test rollbacks actually pretty well without actually latency is frame drop, packet loss. So right now we have lag. Let's add packet loss. Maybe add a little bit of lag too. Let's combine them. Oh, did not like that at all. Definitely did a full desync at that point. Oh, I think we're definitely seeing rollbacks at this point. This looks more like it, actually. So we fully desynced. All right, y'all. Thanks for coming by. We're going to do the next stream, continuing where we left off by limiting the frame, limiting the game forward simulation so that we don't get this desync situation that keeps happening here. Maybe I'll adjust the game a little bit to make it more obvious that rollbacks are happening. Maybe I'll change the color instantly so you can see it. Maybe like a smooth transition on one side and the other side will be instant. I don't know. We'll see. But anyway, I think I had a good little session here, and see y'all next week. Until then, enjoy your evening. If you're out here, out here on this side of the world, have a good day. Well, see y'all later. Peace.